Welcome back to Math 2. So 3.1 with finding the distance and the area. We're going to finish off these notes with these last two problems. Okay. Alright, so the last thing we're going to talk about is dividing a segment proportionally. Okay. Alright, so if it's required to divide a segment proportionally, divide in equal parts or given ratio of parts. There are two common methods used. Okay, so here we're given the scenario. Chuck and Nate were asked to find the location of a point that is 1/3 of the distance from a ball, okay, with that point in the hole. They each worked the problem with a different method as described below, okay? So you can read through these problems on your own, okay? But I think that Nate's method is a lot easier, okay? Because with Nate's method, he found the slope, okay? He found the slope between the golf ball to the hole, and then that's how he broke up the segment into 3 equal parts, okay? And so let's read his part. So he thought about the slope of the line between the golf ball and a hole. And so first let's find that slope. So you know the slope is rise over run. Okay, so let's find out what those points are. Okay, so rise over run. Oops. Okay. Alright, so then when we count these points, okay, when we count all the units, when we rise, it's going to be 12. And then the run, okay, is 15. Alright, so the slope is 12 over 15. Okay, so then once he finds the slope, if I want to find a point 1/3 the distance, instead of doing one large step, I need to break the slope into 3 smaller steps, or just divide the slope by 3. Okay, so he divides the slope into 3, meaning that he divides the top and the bottom by 3. Okay, so 12 divided by 3 is 4, and 15 divided by 3 is 5. Okay. Alright. And then after terminating that, the coordinate is easy. Alright. Okay, so this is the easy part. Okay, so if I want to find out the 3 equal parts from the golf ball to the hole, okay, I rise 4 units, and then from there I run 5. Okay, so then let me show you. So we go from the golf ball 1, 2, 3, 4, and then from here I run 1, 2, 3, 4, 5. All right, and that is my first point. Okay, 8, 6, and then from here, okay, I rise for 1, 2, 3, 4, and then run 1, 2, 3, 4, 5. And there's my second point, which is 13 over 10. 13, 10. Okay. And then from here, I go 1, 2, 3, 4, 1, 2, 3, 4, 5. All right. Okay. So these are my 3 equal parts. Okay. My 3 equal parts that evenly divides this segment into 3 portions. All right. Okay. So then, now, okay. So use this method to calculate the distance and divide this segment proportionally with number 6. Okay, so we need to watch the axis counting. All right, so what that means is that we need to watch the axis, meaning find being careful like where the slope is. Okay, so your slope is rise over run. Okay. All right. Okay, and then again, don't forget your rise is the change of your y values. So it's your y over your x. Okay, your y over your x. All right. Okay, so A wants us to calculate and label the length of JH, okay, and beware the axis. All right. Okay, so JH, we can use the Pythagorean theorem for this. Okay, so it looks like we rise. Okay, so we rise 6 from H, and then run 4. Okay, all right. Okay, and then here's our 90-degree angle. We need to find the distance between J and H, which is our C, our hypotenuse. All right, okay, use the Pythagorean theorem. So 4 squared plus 6 squared equals c squared. And then we have 16 plus 36 equals c squared. All right, continue to solve for that. We have 52 equals c squared. Get rid of the power of 2, square root both sides. And then we have c equals the square root of 52, which I can actually simplify that. So 2 numbers that multiply to 52 are 2 and 26. And then I can break down 26 into 2 and 13. All right. Okay, so now I've broken it down to all prime numbers. So now I can simplify square root of 15 and 2, which is my pair of 2, to 2 rad 13. All right, so here is my side. The distance between J and H is 2 rad 13. All right. Okay, so now that I found the distance between J and H, okay, let's use either Chuck or Nate's method to divide JH and create a new point P so that the ratio of JP over JH is 1/4. All right, okay, so that means, so 1/4, okay, that means I need to break the segment proportionally into 4 equal parts. Okay, and to do that, I need to find the slope. All right, so again, rise over run. Okay, so your rise is your y, and then your run is your x. Okay, so we go up 6, we went up 6, 1, 2, 3, 4, 5, 6 on my y-axis, and then we ran 4, 1, 2, 3, 4 on the x-axis. So my slope is 6/4. But then if I want to break it up into 4 equal parts, I need to divide the top and the bottom by 4. Okay, so then 6 divided by 4 is going to give me a decimal 1/2, and then 4 divided by 4 is 1. Okay, all right. Okay, so if I want to, that means I'm going to rise y. Okay, I'm going to rise 1.5 and then run x. But I need to do it from J to H. So I'm going to start right here. Okay, so J. So I'm going to run 1. Okay, so I run 1. Okay, and then I rise, or I go down 1/2. 1, 2, 1/2. Okay, so this guy right here. Okay, all right, so that is actually my new point. Okay, that's my point P, because that's the first point we found when we went to from J to H. Okay, so my P is it's -4, 1. All right. Okay, awesome. Okay, thank you guys. All right, if you have any more questions, please let me know. If you have any